Let's get started. Hello, everyone. We should do something to the meeting number as it approach 100. That feels too much.
Yeah, we'll just start calling it 1 again.
Yes.
New meeting, number 1.
Yes.
Call it new meeting.
Great.
Maybe we'll change the style though.
Oh, yeah, we'll see.
Yeah.
Okay. Let's start with company update.
So we launched a new product this week. We got the Tinybox Green overpriced edition for people who love VRAM. It's not really overpriced. It's a pretty good deal. We sold one so far. So yeah. I don't know. I tried some new marketing with a product for the GPU middle class. We'll see if that works. Yeah, I don't want everything but the kitchen sink. I don't want libraries like this polluting the repo. We'll get to that later.
Okay. Are we still doing the nano chat training? It's Monday.
If he's down, I'm down. I thought he already surrendered, but if he's down, I'm so down. Let's go. I'll even have the machine too. We ordered the GPUs. We ordered for the RTX 6000 Blackwell Pros. So we'll have both machines. Happy to benchmark it. Look, am I really trying to take 10K from some Twitter anon? It depends how rich he is. If it turns out he got big rich in some startup, yeah, I'll take his 10K. If he's like some kid, I'm gonna take his 10K. Yeah. But no, I mean the other thing that I want to talk about for this meeting is I'm basically here to support the four of you for whatever you need to get the contract done, and have me do things that nobody else knows how to do. Or if there's nothing pressing, I could also focus on just general testing, stability, mutation, fuzzing, like people's, just general bug and cleanups. But yeah, I mean, I think it's really going to come down to what any of the four of you need. Because I think every part should be covered.
Yeah, we just need a drive to do the contract.
What do you mean? A drive?
You're the one that's most excited about the contract.
Well, the contract's sick.
Yeah, that's the difference.
What's wrong with the contract?
The drive to do the contract?
What's not exciting about it?
I don't know, every part of it.
Why? Do I have to do it? Like,
yeah, I don't know.
Is that what you want me to do? Like, do you want me to start working on the training script?
I don't think with bottleneck is training script, but anyway, yeah.
Well, no. What do you mean? What needs to be done? Right, that's the only thing I really want to talk about in this meeting.
Oh. I don't know. I mean, I'm neutral. I don't know what other people feels about the contract since they didn't involve in the first part of getting the contract.
No. Like, this company's doing the contract. I want everybody focused on the contract.
Yeah.
The contract is we have to succeed at this, or this is over.
Yep.
Like, this company's over if we don't succeed at this contract.
Yeah.
Yeah.
That's the part I don't.
You don't agree with that?
I don't have a strong opinion.
No, I think if we fail at this,
Okay.
like we said we were going to do this, if we fail at this, I think I'm shutting the company down.
Okay.
Like, I think there's no point in continuing if we can't. If we've come this far and we can't. If we have $5 million, we'll give it back to the investors. There's no point if we can't do this.
Okay. I mean, I don't know how other people feels about it.
I mean, that's just from the top down. If we don't succeed at this contract.
Which part of that ties to a company mission?
What do you mean?
Like, no one is going to buy MI350, right?
I don't care about that. If we can't succeed, if we're so far behind the state of the art that we can't figure out how to get on MLPer for a big llama on a modern machine, let's just throw in the towel.
Okay.
Like, what are we missing from being able to do it? Okay, it sounds like I have to do it.
Drive of doing it.
All right, so it sounds like I have to do it.
Yep.
Okay. All right. I don't have anything else to say for the meeting then. That's it.
So, Quasaline, the only thing to discuss about is QTT. So if you will find out that Rock Prof v3 works fine, So I think I'll look into these. Because currently our runtime doesn't meet any markers. I doubt actually.
Rockblock doesn't
that's
even capture it. Like Rockblock is
yeah, on
for that.
Look,
yeah,
I mean,
you can.
if we can't succeed at this, we're just talking about this offline. We'll talk about it in the meeting. If we can't succeed at this contract, like it's not a question of if people are going to use Tinygrad to train Big Llama. It's a question if we're so hopelessly lost from the state of the art that even with as much hand coding as we want, we can't get this thing to train.
Okay.
If we can't do that, then like
No, I mean, I have no doubt we can do that,
Okay.
and we will do that.
well, let's
but-
get paid $2 million and let's do that. There's $1.6 million on the table of pure profit,
Okay.
right? Like
I mean, I don't know. I'm not motivated by $1.6 million.
it's not about the money though. It's about like
What's it about?
what?
So I already know if we spend time to handwrite these kernels, we
Yeah.
are able to go into train a model on the MI350.
Yeah, let's do it.
No,
Well, but what do you mean?
what's the part that's exciting about this? You already know we can do it.
No, I don't. And like I don't see any better way to push Tinygrad forward than to actually try to do this.
Yeah, maybe that's the problem.
What do you mean? You think there's a better way?
I don't know.
I really don't think so.
Okay.
Like again, this is what everyone this is what Chris Latner said to us. He's like, I want to see speed from your thing. Tinygrad is hopelessly slow.
Yes.
That's the main problem with it.
Yeah.
Right.
When he say that, he doesn't mean like see how good you can handwrite these kernels, right?
He does. Oh, he does. And this is what Mojo is.
Okay.
He didn't write an AI compiler. He says it's impossible. The greatest compiler guy in the world says you can't write an AI compiler.
Okay.
Well,
That's the issue, right? So if we believe in that, then maybe there's no point for Tinygrad. Maybe we already lost to Mojo.
no,
How can we beat Mojo?
in a lot of ways. And it's not that we can't beat Mojo. It's about the timelines. The same as Tesla. It's the same as Comma and Tesla, right? It's not, if we looked back and at Comma, we were talking about building driving simulators right at the beginning of the company.
Mhm.
But the technology just hopelessly wasn't there. Right? You look at the original learning and driving simulator paper, and all you see is like little grainy images. Right? And it's not that we got any better at data collection or training or anything. We just waited for the state of the art to improve.
Mhm.
The same strategy, I think, applies here.
No, but here we already know what the state of the art is.
No,
Are we
but
going to write better kernels than what people are writing now?
that doesn't matter. We're going to write simpler. We're going to write something that's actually machine searchable.
Okay.
Right? But like, how are we supposed to know on what areas to push if we don't have any state-of-the-art kernels in Tinygrad?
Sure, that makes sense.
Right? Like, we committed to this contract. We have to do this contract, and the only way I would consider focusing on anything else is if someone else was offering us more money. And it's not about the money. It's about it's worth $1.6 million to somebody else.
Is it low?
Yeah. Why?
I don't think it is.
Why'd they give us the money?
For other reasons,
Like what?
like the potential bugs or the things we can find to help them.
What do you mean? But that's,
It's not clear this task is worth $1.6 million to them.
it's easily worth $1.6 million to them.
Yeah, I mean, maybe that's a difference, right? You believe so you have the drive.
Wait. What? You think I bullied him into it? You think somehow, like,
Yeah.
no.
They were more, this is more like their marketing or developer advocate fund, right?
Well, yeah, but of course, the goal, I'm not saying that the $1.6 million is literally because Tinygrad can train a llama. Of course not.
Okay.
But why would you not want to fund
Yeah, but
alternative approaches. Of course you do.
yeah, of course you do. But that doesn't mean it's worth that money to you. That's more like a hedge.
No, it's worth that money. If we succeed at this, it's worth that money to them.
Okay.
Wait, you really don't believe that?
No.
Why? If I had hardware, if I had a hardware company, and I could pay someone $1.6 million to build an alternative stack that succeeds at training the state of the art on my hardware, I'd pay that in a minute.
Okay, I'm not doubting you believing that, but just I don't believe in that.
But what do you mean? The tape out of that chip is $150 million.
Yes.
If you paid $150 million for tape out, why would you not put $50 million scattered randomly into software?
Maybe they do.
Yeah. And then why would you not want these software projects to succeed at exactly that goal? I think it's a smart. So you think it's a dumb goal? You think that AMD should have asked for something else? Or you think there's nothing we can provide to AMD that has value?
It's not clear what we are doing provides value to them, at least to me.
Why?
It's just not clear to me. Maybe I'm just not educated. I don't know.
Well, but okay, so
because you start this, you have the most of the communication with them, right? So maybe you know better.
no, I mean, look,
I mean, look, I know like part of it already. That's because I'm in the office and talk to you on this. Like what other people think, I don't even know.
well, I mean, again, so okay, you think
I think this is a good challenge, and I think we'll be able to do it. I would like take the training round. It's like whatever days that will probably be done at the end of this. Yes, but I don't quite see what's the difference for the company. Like, what do we do after that and things like that.
what do we do after that? We figure out how to do that and make it easy.
Okay.
We figure out what we didn't do for the DSP contract because there's no real market for using time. There's no real market at all on these DSPs. No one uses them. But
Yeah,
a ton of people use MI355X.
And they will use Tinycorp.
Probably, yeah.
Is that our direction?
Yeah.
Okay. I don't quite see that, but
What do you think they're going to use?
Jax?
With the MI355X?
Yeah.
Have you tried it?
No.
Yeah, it doesn't work.
Yeah, but it's similar to Tinycorp doesn't work today. Right?
No, Tinyguard works better. I don't think Jax works at all.
Yeah.
Their GPU thing in Jax is way worse already. And you know, if anyone put any effort into it, it's on NVIDIA.
Yeah, maybe.
The GPU backend on Jax just kind of isn't there. Jax is an ad for GPUs. The Jax backend is very good on TPUs.
Or just handwrite these kernels, right?
What do you mean?
If you're going to do a big training round, it's just handful kernels.
Yeah, but what about all the people in the middle?
Who are the people in the middle? Who is going to use something in the middle?
Every researcher.
Is Kama going to use Tinygrade to train?
Not soon, because they're on NVIDIA. But if Kama was forced to use AMD hardware, yeah.
So you think if we do this contract, Kama would be more willing to use Tinygrade for their training?
No, I don't think they want AMD hardware. I think if we
Okay. If Kama is not really using, who are these users we are talking about that potentially would use Tinygrade for training?
What do you mean? Again, like, why does anyone buy AMD hardware, right? People are buying it, right?
Yes, very little amount of people.
A very little amount of people. Look at AMD stock.
Oh, it has nothing to do with the sales.
No, it does. But it absolutely does. AMD sales are way up.
Way up and still tiny, right?
I mean,
If Kama is not.
what do you mean by tiny? You want to compare it to Tenstor and Grok?
Grok has users. Buys their hardware while they have users. That's different. They have
I have a lot of questions about whether Grok actually has users.
Yeah, I don't know.
I think they lose money on each of those
Okay,
inferences.
my point is, do we really have users who will be willing to use Tinygraph for training a bit, Llama or anything like that?
Yeah, but it's not like training Llama is some crazy task that.
Yeah, that's what I mean, because it's not a crazy task. You just handwrite 10 kernels, or people already write it for you
Yeah,
on
well,
Torch.
but let's get those 10 kernels handwritten and show that Tinygrad can get performance like that. Can you come up with a better task?
Maybe no.
That's what I mean, right? And we're getting paid $1.6 million for this task.
Yeah. I don't know.
Like, okay, if no one else wants to do this, I'll do it.
Yeah, I'll do it, but I'll do it, but probably similar to previous ML perf, right?
What do you mean?
It's like, does the previous ML perf give us anything?
Yes.
It's like what?
I mean, that was a great direction. That got us building out, like, we fixed so many bugs.
Yes.
It didn't get us speed, but it got us the whole front end. The whole front end, all the stability of gradient and stuff. But that all came from the previous ML perf.
Maybe come from the first two. But what about the one next?
Which one next?
So we have ResNet 2 years ago.
Yeah, okay.
Then we got BERT the one
Okay.
after.
Sounds good.
Okay, what about the two after?
Did we even submit? I think
It was something like two.
we did speed ups for one of the birds, but no, I don't think they were that.
No, I think we did something this wrong.
No, I think that it was important to get ResNet and BERT. But yeah, I mean we have to go back to succeeding at MLPerf and we have to start getting good times.
Cool.
What else is there to do?
That's a great question. I don't know. But it also feels weird that the only thing that possibly can help people is doing MLPerf training around.
But it is. It's just not fast enough yet.
Yes. Okay.
What else is there to this? Multiple.
I mean, I don't know, right?
I retweeted 2 people last week who were like, TinyGrad is way better to use than PyTorch. It's just slow.
Do they use this for training?
To use it for research. Yeah, so I'm sure. I bet they even use it for weirder training than PyTorch.
Okay.
The goal also is not like if we do this in such a way, it'll work for everything that's kind of like Llama too. It's not just Llama.
Oh, sure. I mean, yes, you got the similar transformer stuff or attention stuff.
But not just the transformer and attention stuff, right? Like the
Okay, what else?
well, it's not like we're handwriting kernels in HIP, right? I'm not proposing that.
Oh, sure. We handwrite kernels in UUP.
Yeah, okay.
Okay.
But I mean, do you see why I'm pushing for that? Because I don't know how to improve the search.
That I understand. Yes.
Okay. So what better thing to do than instead of to make up some contrived kernels, do the kernels that they're paying us $1.6 million for?
It's fine.
Maybe it's fine. I mean, this contract's the best thing ever to come to this company.
That I agree.
Okay, then let's complete it. If we fail at it, the company's over.
That's the part I'm not motivated about.
What do you mean? I mean, look, I'm not here to motivate you, right?
Yeah.
Like this is what we're doing, right? You can
Yeah,
stay with
yeah.
this company and do this or not, right?
Yeah.
That's just how it is.
Yeah. Cool.
Yeah.
Okay.
I mean, I don't think we really have like much else to talk about. Like anyone here who's not motivated to work on this contract should quit today. Think about whether you're motivated to work on it. And then also let's figure out what everyone knows how to do. And then whatever anyone doesn't know how to do, I'll do. Okay? I'll do this whole thing myself if I have to. I'd rather not. But yeah, I mean, I've taken an approach where I think I can. I did the DSP contract mostly myself.
That's another thing, right?
What?
What do we get from DSP contract?
The entire devectorizer and expander stack.
And okay. What have that changed?
What has the devectorizer and the expander changed?
Yes.
Like it supports things that are just like the old one was hand-coded garbage. The old ones hand-coded float 4 everywhere.
Okay.
It forced us to genericize to 128. Right now, things like upcasted warps are possible. I mean, again, I'm open to a different proposal, but I need a concrete proposal.
Yeah, I'm thinking about it. So I cannot think of it now. Okay, maybe other people should talk. Other people, are you excited about the contract?
I am.
Yeah.
And it's the first step, right? If we can't do this, search can never accomplish it either. So
Yeah, I mean that's kind of my takeaway too, right? It's not like there's any reason to like look, I don't care how long this is going to take. This is going to work. Right? I don't care if it takes 6 months, I don't care if it takes 5 years, I don't care if it takes 20. This is going to work. Right? It has to. Right? It's the same thing with end to end. It's the exact same thing with self-driving cars, right? Like look now, Tesla's saying end to end, Waymo's saying end to end, everyone's saying end to end. I said it 10 years ago and I was like, this is going to work. Is it going to work in 6 months? No. Of course not. I have no idea how long it's going to take, but it's obviously the right approach. This is obviously the right approach to software. I don't know, like there's going to be, you're going to do things along the way that look stupid, right? That was brought up at Comic-Con, right? Like a lot of like things you do along the way look stupid, but it's not like you can do it better, right? You just got to accept that. And you just keep working on it and that's it. Like fundamentally at the end of the day, this wins. Porsche definitely doesn't win. I think Mojo carves out a non-AI niche or things that just can't be expressed in the Tinygrad language. I think Jax does well, but I think we're really using a lot of the same ideas as they are. And I think Jax, again, is mostly an ad for TPUs. So yeah, I mean, of course, if Google wasn't thinking like Google's thinking in the exact same way, but as what always happens with these things, Google's infrastructure is multiple years ahead of the rest of the world, but they somehow completely fumble the ball at shipping it, which is exactly what will happen here. And then the open source one actually is the one that gets all the adoption. Like yeah, like we gotta take all the ideas from the good ideas from there's a lot of smart people in the space. Jax, TVM, Mojo, PyTorch, they're written by very smart people. And we got to take the best ideas from them. But then you do it and you keep the whole thing simple. These people end up with every, thing. It's just like, sure, you can write this with 10,000 lines of hacks, or you could not. Right? And now you can say, like, all right, I don't want to hand code kernels. We should just focus on search. We should just not hand code kernels. Like that's an approach. There's two problems with that. One, if we do that, we're not gonna finish the contract on time. Right? There's no way we're gonna find that flash attention online max. The rules to search for that will be, again, I think we can have them in a year, but I don't think we can have them in 3 months. The second thing is I wish I'd spent more time hand coding kernels before I worked on search the first time. Or I wish I'd read more kernels. I wish I'd not read SNPE, and I wish I'd read all the state-of-the-art H100 kernels and stuff. So what better way to force us to read the kernels than to actually write the kernels, but in our higher level abstracted language? Instead of writing the kernels in, because finally, if your middleware cannot express the ideas, your front end can never ever find them. You have to make sure that your middleware can express the ideas, right? And I did a whole bunch of things wrong because of that. But everything's fixed now. Like with Rangerify and stuff, like that's fully state of the art. There is no, I remember a few people brought this up. A few people who worked on AI compilers like brought this up when they saw Shape Tracker and stuff, and they're like, "Well, how do you do locals?" Like, well, here we have these like things to do it, and they're like, "Yeah, that's not generic." But the Rangerify one is fully generic and modern. It can do everything Halide and TVM can do. Yeah, I mean, I'm curious, and the thing that we really need to find out is there anything that our language can't express? Because if there's something our language can't express, it's so much better to figure this out now than to figure this out in, after diving into search and then having to rewrite the search thing an extra time. So that's why we're writing kernels. I'm not asking for 100 kernels here. I'm asking for 4. And they're all cute and different enough in their own way. This is not a lot of repetitive work. Nobody's asking for a kernel for conv2D transpose dilated here. We're asking for a kernel that, 2 kernels. We're asking for a gem and a flash attention, which are like the 2 demos in every fast kernel library.
What happened to conv2D? Do we have the best conv2D? Do we
Okay.
plan to? What if the researcher wants to use conv?
Then in 3 years, the automated search will be good.
Okay.
Or they're welcome to write it in the UOP language, which should be fully documented and fully interop. I mean, really, the UOP language, right now we have this tensor.custom kernel, but we shouldn't have that. There should be no reason that you can't.
You just construct a URL and throw it to the tensor.
Yes. You should be able to fully construct all of the kernel stuff in the big graph, and it should just work. I think it's all differentiable too. Now, your derivative may not be a smart way to do your kernel, but that comes down to that's like the sigmoid trick again. So always going to be stuff like that. Right? You can express stuff as like, yeah, there's probably, we probably have some syntax to like, you can write stuff in tensor and be like, no, I want to override this derivative with this other stuff also written in tensor. I mean, the way that this goes is like, so more and more things migrate out of tensor and ops into mixins. So tensor will just become this very small wrapper. It's really a container class for UOP. It holds a pointer to UOP, and that's pretty much it. Yeah, and then you have this like language that you can use. I mean, tensors and UOPs are basically identical. The only time you use a UOP instead of a tensor, you can use a UOP instead of a tensor if you never actually want to reference this thing later. The only thing a tensor is this a pointer to UOP. So you can keep this pointer around, and it promises you that. Yeah. Like if it realizes the buffer, that realized buffer doesn't actually change the UOPs because UOPs are immutable. The tensor is what actually changes. Yeah, I mean, I need everyone here working on this contract. That this is the entire company depends on this. If we fail at this, I think we should shut it down. Because if we can't do this, we can't do this. But I don't see why we can't. Let's just do this. All right. I don't care how much we have to hand code. We'll clean that up later. We'll actually clean it up later. Or we won't. Or it'll be like the DSP contract where we don't, and we go to something else, and that's fine too. Right? You take whatever learnings you have away from this. But there's no better way to actually make progress on a piece of software than to try to use it to actually do something.
Okay. I think you were discussing SQCT before we joined back.
I can talk about SQTT. So I merged the UI in this. Right now it's using the ROCm decoder, which you have to install. I think like if you run with SQTT equals 1 and with, you'll see if there are any error messages, and it will guide you through how to download the decoder. I did some work on just writing assembly kernels and then timing them, comparing ROCm's stuff with the AMD tooling, the other one, the RGP. And I find a lot of discrepancy, and I have no way to debug it because it's like a closed source thing. It's basically a black box. So I just find myself keep giving on, like not knowing what's going on with the decoder. But sometimes it's just wrong.
Does the RGP tool link to that decoder and use it?
No,
I
I
doubt
think
that.
it uses a difference.
Oh, okay. Then this is unmaintained crap, and we have to write our own.
That's what I'm planning to do, I think. I was going to bring it up in here.
No, actually, like the Linux tooling, which is like RGP is like for gaming and this stuff, and for AI is this tool that we use. And I think the first thing is what we really need to do is just to compare the ROC prof, like their own Linux profiler, and yeah, see what results it shows.
Yeah, that seems reasonable.
I ran
Yeah,
I ran
it
ROC
works
on
on
TinyR7. I ran it on
Yeah.
TinyR7. It doesn't still show the stuff that I wanted to show. Like on my tests, on simple matmul, yeah, it showed some things, but like on some other tests, it's just empty. Like the whole problem with all these external dependencies is that I have no way to debug it once something
yeah,
is wrong.
you need to limit shader engines. So our runtime does that automatically, but I think you should provide some variables to HSA. Because actually they capture only like the first shader engine. So yeah, you need to limit this somehow. And that's definitely possible. I've seen somewhere in the docs. I can look into this. And actually, maybe we also can validate, I think, MI350, maybe it's their primary target, so we can just see if it works fine on MI350 and make this work for the contract.
My guess
these
would be the
QTs are
best
there.
supported GPU is MI300. It seems like their stuff for MI350 isn't quite there yet. But yeah, I mean, we can try it. We can try it on either. Yeah, I mean, I like the idea of just comparing it to the AMD tooling, seeing what they're using. I mean, I'm also interested in just starting to parse SQTT ourselves. It's very interesting what like we're gonna have to eventually, because like what's the GPU actually measuring? That's the interesting thing. I don't want a lot of the abstractions on GPUs are really bad. Like there's whole idea of when you type float A in CUDA that's actually a float vec32. This is a wrong abstraction. It might have made sense for gaming shaders, but it doesn't make sense for AI. So yeah, I like the idea of just cutting through all these GPU abstractions. We can start on our own, but don't get too lost in a rabbit hole. Stick to things that are grounded. And if we don't replicate RGB perfectly, I want to know why.
Yeah. I'll try to see if like we are doing something wrong. Maybe it's not our problem. Yeah. Even like the simplest stuff that I write mismatch. That kind of like I want to understand what the actual blob that SQTT is outputting is. On my USB GPU, I have so many bugs. GFX 11 is much nicer. I can SSH into the tiny box and most of the stuff that works. The USB GPU crashes every single time. That's why I kind of have this focus
Why
a
is
bit.
that? Is that because of GFX 12 or because of the USB?
You
You
think the
could try.
USB has anything to do with it?
Well, if you think it's GFX 12, try it on Tiny H3 and see if there's the problem. I think it very well could be the USB. You're on USB 4, right?
Yeah.
Right, that should have less bugs, but yeah, I mean,
What do you see? I mean, like,
Oh, it just crashes. Like it gives very random counter values, like very huge 32-bit numbers that absolutely make no sense. Or sometimes negative counter values because something overflowed.
see if you can reproduce it on H3, which has a GFX 12. You have a GFX 12 on the USB GPU, so
So I think
But-
our plan is to first start with ROCm stuff and then
do you think it's the USB or do you think it's the 12?
I know I've tested my JFX 11 on USB with SQT and it was fine. I don't know, really.
Yeah. I don't know, but yeah, if you're seeing problems, just like figure out the simplest way to reproduce them and post them, and we'll improve whatever it is.
Hey, how good is our tiny kitten?
It works. It's not very fast yet. Working on correctness first. But
So does it differ from how Thunder Kittens is doing it? Like, are the registers in the same place and the locals in the same place?
yeah, so all the indexing matches Thunder Kittens exactly. And then the only things is I've disabled all the optimization so I can actually read all the kernels. So like nothing's upcasted, nothing's unrolled.
That really kind of shouldn't matter, especially with CUDA.
There's some stuff that I haven't implemented yet, just so it's easier for me to think about the kernel. So local swizzling isn't done. So there's SMM bank conflicts.
Oh yeah, I mean that one's
Yes,
gonna kill
that's
you.
the big
So
one.
it's not
That's the
the
big
same
one.
index.
Yes. But they do that very. They just have a function on the like SMM tile called like .idx, and then you pass it a standard index, and it gives you the swizzled index back.
Yeah,
So
yeah, we
I
can
just
write that same
didn't
function.
do that function. Yeah. So I just didn't do that yet, so I can think about where stuff is placed.
Yeah, I mean that's the so the key thing to do for tiny kittens is to get fast gems everywhere.
Yeah.
Like yeah, and just make sure that every byte is being accessed in the same order in both tiny kittens and thunder kittens.
Mhm.
Yeah, don't worry about upcast, don't worry about unroll. Those things don't matter.
Yeah. Also, really bloats the kernel source.
Yeah, it makes it hard to read. I mean, so upcast itself doesn't matter, but doing the split does matter. But you can use .loop. If you look at
I see.
the AMD UOP matmul, there's just a bunch of like tiny loops, and those tiny loops will be automatically unrolled by Clang, and it's the same.
But yeah, the initial thing I merged should is almost has everything to do flash attention. So
Cool. But yeah, no, I mean we need gem speed. We can't have more things in TinyGrad that don't get gem speed. Someone 2 years ago was like, why don't you just focus on making gem fast? Why is your gem slower than other people's gems? And I think 2 years ago that was the wrong thing to focus on, because if we tried to do that, we would have ended up with a ton of hand-coded crap. But now I think we're to the point where we need to focus on making gem as fast as Kublas on all of these GPUs, as fast as Kublas, as fast as Rockblas. Yeah, we got to have the fastest gems basically. And if we can't have the fastest gems for some reason, we got to figure out what we need to add because we know it's possible. Yeah. But no, I mean, I think that the way that the UOP abstraction works, it's hard to write anything really bad in it. Like in CUDA kernels, you can write things that are just really bad and that nothing could ever reason about. But I think in UOPS it's kind of hard.
Yeah.
Yeah, and I mean, and then we can like, I think for a lot of things, I think like I was thinking about like, yeah, the max unrolling and flash attention, right? Like the way to really write this search is not to, like with the A range, I think it's similar to the A range folding. With A range folding, it was easy to know what the kernel should be, but in this one, it's kind of harder to know what the kernel should be. But it'll be nice to have the two side by side in Viz. Oh, here's the one with the max. Here's the one without the max. Okay, cool. Now I see the transformation, and we can think about if that transformation can be broken into pieces, how we might want to search and find that. And I think there's this intermediate stage as well where, like, the beauty of the hand-coded kernels is all the optimizations still work on them. So we could get to a point where you can write the hand-coded kernels in a dumb style. Like, it's the full intermediate where you can write them in a dumb style and apply the optimizations to them. Like, the one of the things about TinyGrad that is nowhere else is that we have this unified op space. It's not perfectly unified. There are sometimes different ops that you can use at different times, but this is becoming less and less. You can now like use movement ops. You can use movement ops in the UOP kernels, and then applying an index to a movement op can actually be done as late as you want. So the goal is to eventually unify this entire space so every op can be used everywhere. Some ops can just be removed, and that's the magic. Oh, on that, one of these projects that we have to do, someone's got to do this soon, is removing images from the high level. Images should not be a tensor D type. Images should be a load and store optimization in the kernels. It's not that we have to focus every single thing on the contract. We just have to focus 70% on the contract.
But how do you apply comp2D?
What do you mean?
It's like Winover, right? At a very high level, you use a different algorithm because you know later it will be optimized.
Oh, for images?
Yeah.
So, okay, the images are two things. So it's actually not a different algorithm. The algorithm for images is identical, but the memory placement is different. So it's a permute. It's just a permute on the things. But I'm even saying to keep that and just basically use like image equals 1.
Yeah, that's what I mean. Yeah.
Yeah, but you can even keep that out. But that algorithm, it's not Winograd. It's not that complex.
Winover is also not that complex. It's about the same.
Winograd's changing the math. The image conv doesn't change the math. It's the same math. It changes the order in memory. It's not NCHW. It's not NHWC. It's NC divided by 4 HWC mod 4. Something.
Yeah.
Something.
Yeah.
And these turn out to be a lot of the fast formats on hardware. The DSP. That was another big win from the DSP contract. Like it made me realize that is the key optimization, and we can do it now. With buffer horizon index, you can arbitrarily split and permute across the buffer horizon index. And you can do this in such a way, it's really nice because you can do this using movement ops on the bufferize. So you're like, what if the bufferize has 2 index children? Well, if I want to permute it, all I need to do is switch them in the bufferize and then stick a permute op on the bufferize and then run PM mops, and it munches the index up to the bufferize again. So yeah, like it's really cool that that's an optimization that you can just apply to the bufferize to completely change memory layouts. And memory layouts, I mean, memory layouts, this local swizzling thing is memory layouts also. Also, one of the things that Flammet used to bring up was the common pattern often for locals is to XOR. And now we can do that. There's nothing about index that doesn't support XOR.
How do we do that?
Put in XOR.
That's right.
Just put XOR in the index.
Or just as a new op.
No, we have XOR. I don't need a new op.
Oh, okay.
Just use index and with an XOR. I mean, you can't do it with a movement op, but everything else works. You don't need a new op because it's just a transformation on the index. Chris M, I see you in here. How's the new autogen coming?
It's good. It's like pretty much ready for review. There's like one thing, the NVJIT thing is kind of broken. I wrote this up in the PR about specifically why that's going on, but basically the old Clanktify was translating the file incorrectly, but then it just so happened to be exported. So we got to figure out what to do about that. That seems like we honestly might need just to hard code a case, which is a little annoying. But Objective-C works. It was a little more complicated than I thought it was going to be because of inheritance stuff in Objective-C, but it works now. So that's
Great.
like, I have to fix some MyPy stuff, but other than that, it'll be ready for review like this week.
Awesome. Yeah, I'm super excited about this. I was playing with Mutt and coverage last night, and so much of this is dominated by all the crap autogen stuff. So I'm hoping this new one looks nicer. Yeah, I'm very excited about this.
Yeah, should be good.
Yeah, I mean, even if it doesn't look nicer on the drop, it's kind of like now we can at least control it. That Clanktify tool was so. Every time I've tried to edit it, I'm just like, someone's got to rewrite this. So I'm really happy it's getting done.
B1TG, you want to say something about AMD FP8?
Hi.
Hi.
Now I only quantize Q and K, either in the even index or in layers. The loss can goes down now. And next, I need to try the other combination and try the faster FP8 tensor core, the 60 and 128 tensor core. I already get it works better. The beam can't search the fastest kernel every time.
The beam does find the fastest kernel with the 16/16/32.
Yeah.
Cool.
And seems beam can only use only one tensor core shape for the specified input out D type every time. Is that the expected behavior?
I mean, yeah, you can add more stuff to the beam search thing, but I think the real thing to do is that we just kind of that API boundary isn't great. Right now, the fact that we have this other language called opt-ops to apply optimizations, what you really want to do is graph rewrites and add something like a choice UOP, where if there's 3 different ways to do the map mall, cool, it puts in choice, it puts in the 3 map malls, and that's it.
Okay. And another thing I'm gonna do is make the train works across multi-GPU.
Why would that be different for the T-type? Anything special there, or just need to making sure it's correct?
You mean the tensor core?
I mean, you said the next thing you are going to do is multi-GPU is because you need to validate that's correct, or you already see something that's different for multi-GPU? Because I expect it to be kind of free, since now also multi-GPU works, and you are just changing some T-types.
Multi-GPU costs the MMU.
Oh, okay.
Oh, is that related to the tensor cores, or is that something else?
It then caused by the FP8, it
see.
can reproduce using the half train with masked code.
If you can find the smallest repro of that, that would be great, and then we can look into it.
Yeah, so try doing some or reduce examples on multi-GPU, then trying to do a memo by sharding like one of it on multi-GPU. This two should give you an idea for like what went wrong in your training.
Okay.
Cool.
I'll say another thing too about custom kernels. Like I said, like I don't see this ever going away. This is not like this is I think even less specific than the DSP thing. We always want to support people writing custom kernels.
Yeah, I don't have issue with custom kernels.
Yeah. I mean, it's not, this isn't like some, right? This doesn't violate the Tinygrad, like, one of the goals is to never have abstractions that leak. Right? You never want your abstractions to leak at all. Oh, we just have this one thing. We just have this. No. It's all gone. It's all gone. As soon as you have one, you throw it all away. But this isn't leaky abstractions. This is simply letting you tap into the entire abstraction stack. We have the same philosophy at Comma about hardware. I say that I want to sell all the intermediates. Right? If we use jungles to bring up Comma devices, we sell jungles. Right? Like sell that, turn it into a product. Right? For every one of our APIs that we can effectively turn into a product that's an intermediate in Tinygrad, it'll be better. Be better because we had to put some polish on it to productize it. Now you shouldn't productize things too early, right? If things are going to rapidly change, sure, all the effort put into making this a product is a waste, but I don't think that the custom kernel syntax is going to change too much. You think it's going to change a lot?
I don't know. I mean, these things is hard to predict.
Well,
because many things have changed, and it's very annoying when I was bicycling stuff with my custom kernel to the previous ones.
Yeah, I mean, like, sure, I think that, like, syntactically it's going to change. Right? It's not like 1.0 syntactically, but I'm not like, it's hard for me to imagine where you'd have to add, like, think about the device abstraction and think about the last time that changed. It used to change a lot. When's the last time it changed?
Do a competitor pair or something, device pair or something like it should change.
Tiny change. It's pretty much not that.
It's more of a minor annoyance. I mean, similar to tracking what happened to the inheritance. It's syntax, yes, it's minor annoyance.
Yeah. Can you write a custom backward function? Yeah. You can write a custom backward function and you can use custom kernel in it.
Yeah. So see examples in test /test _ custom kernels. There are a few. I think just one backward examples, but that should be enough for you to get started. Sorry, you were saying something?
No, but all right. If I'll just start working on the contract.
Okay. Do we have any other bounty? I don't think so. P8. We have Flame here.
You're Flamet, you're finally getting your fast gems. I was excited also to see yeah, someone had a bug in the custom stuff. It turned out it was just fixed with linearizer updates. It's fixed with bottom up.
Oh, speaking of this, someone raised another issue saying your change made some counts lower.
Probably did.
Okay.
We can't do anything about that.
Hmm?
Like, yeah, I made it slower. Great. Like long term, there's a few approaches here. But the real approach, the reason things get slower is because you've increased register pressure. Your order of your instructions determines register pressure, and LLVM's not that good at reordering things to alleviate register pressure. So yeah. What you want to do is you want to write a register allocator, And then even if you are going to output it to C, which is going to be re-register allocated, putting it in an order that minimizes register pressure is going to give you faster kernels. So that's probably why the speed changes. With respect to like, is Tinygrad going to have the fastest convs? Not in 6 months. It has the fastest convs on Snapdragon 845. Literally, almost no matter how much you regress them, they'll be faster than SMPEs. But yeah, I mean, no, there's no. If someone wants to pay me $1.6 million for fast comms, I will write fast comms. And that's like go where the money is. Not because we need the money, but because if someone's willing to pay for it, it's useful. Right? You don't think there's some chance that like what % chance is it worth it if we end up replacing AMD's entire stack?
Oh, chance?
Yeah, what do you think our chances of doing that are?
0.1.
Why so low?
I mean, you ask, I give you a number.
No, why do you think it's so low?
I'm willing to bet 1,000 to 1.
Versus AMD?
Yeah.
I would give us 1,000 to 1 versus NVIDIA.
NVIDIA is probably even lower.
But wait, why do you think AMD is so low? Have you used their stack?
No.
Try it. Try using AMD on anything besides Tinygrad.
Okay.
It works right up until it doesn't. Right? Sure, the gem and torch is faster.
No, I mean, that doesn't change my impression for this probability estimation.
Why?
Because it's not about that.
What is it about?
I don't know.
But like, why do you think it's low?
No, I mean, it's 1.1%.
No, but why do you?
It's pretty high.
Okay, so I mean, someone's gonna or okay.
So let's just start with not AMD using the.
What do you mean not AMD?
I mean, I don't see how this would happen.
What do you mean? How what?
AMD replace the whole stack with Tinygrad.
Well, okay, so
That's what you ask, right? The probability of that happening.
No, the probability of Tinygrad being the dominant used stack on AMD. I'm not saying for AMD internally to cancel ROCm.
Oh, you mean for people to use Tinygrad on
Yeah.
AMD?
But that Tinygrad is the go-to stack for AMD.
It's pretty.
Why?
That's my impression.
What do you think the go-to stack on AMD will be?
I don't know.
So it's going to be something, right?
Yes.
So do you think it's going to be their ROCm torch stack?
Maybe.
What odds do you give it to be that stack?
Like when? 5 years?
Yeah.
Last act probably 70%, given Smith left.
Okay. So we're at 0.1 and they're at 70. Where's the other 29.9?
Jacks.
Jacks. So you think there's a 70% chance that somehow they're going to hack together the PyTorch stack? There's a 29.9% chance that Google is somehow going to fix all their stuff and care remotely about AMD GPU.
No, it's not about that. It's about what user would choose, which framework when they have AMD hardware. Do you think they are going to choose Tiny? Do you think they are going to choose Torch, Jax? That's our problem, right? The question was the user bought or have an AMD hardware. How do they going to choose which framework to use?
They're going to try all three.
I don't even know that's true to start with, but sure.
What do you mean? You don't think they're going to try all three?
No.
What do you think they're going to try?
Torch.
Okay,
Jax.
so what are they going to do when they hit bugs in Torch?
Similar to what are they going to do when they hit bug in Tinygrad? It's not like we care that much about fixing user.
No. But so you think people aren't going to try Tinygrad, or you think people aren't going to, or Tinygrad's not going to, like, they're going to hit too many bugs with it, or it's going to be too slow, or?
Well, it's very hard to predict in 5 years.
Right, let's say 3. I mean, I think 5's a little far.
Oh, 3, then we just see. I think people will hopefully try it.
I give Tinygrad easily a 20% chance of being the dominant stack in 3 years on AMD. And I give us a 0.1% chance of being the dominant stack on NVIDIA.
Okay.
But I don't understand. Like, if you don't believe that, why do you work here?
No, I mean, because I don't think that's the important thing for the company.
Well, what's the important thing?
I don't know. There's a chance.
Well, yeah, I want you to try the AMD stuff. Like, go try it. Does it run ResNet? Maybe. Can it run ResNet training?
Maybe the problem is I am not a target user to train things on this model, right?
Well,
I train it not because I need to train things on it, so I don't have a motivation to figure out what's the best to train things on it.
so I mean, the question to ask isn't like for comma switching their training to Tinygrad on NVIDIA. That's a really high bar.
Yeah, but if we don't even have a path to that.
Well, I think
what's the point?
We don't have to.
Then who's going to use it if we're not going to use it?
Who's using MLX?
I don't know. People seems to run inference on their Mac happily. I use MLX.
There you go.
Yeah.
Right. It's just the same thing. No. What percent chance do you give MLX of being the dominant framework on Apple in 3 years?
2.
It's that low?
Yeah, of course.
No way.
What do you think? They already give up.
MLX has given up?
Yeah.
Really?
That's why they pivot to CUDA.
MLX is trying. No, MLX is just adding a CUDA backend.
Yeah. And they are training all their resource on that.
Well, no, but
Guess why?
What do you mean? Because they want MLX to be the one-stop shop.
Okay.
MLX people are basically betting on all developers have Apple. But then sometimes you run it in the data center on CUDA, so we want the same MLX code to run in both places.
Yeah. 2%.
On Mac.
Yeah.
Come on, that's way higher.
I don't know. Everyone has a number.
So what do you think the dominant thing is going to be on Mac? Torch?
Yeah, whatever currently is, I think it's Torch.
Well, a lot of these things aren't even Torch. A lot of these GGML, VLLM, they're not Torch. They're just the hand-coded kernel.
Yeah, maybe part of that, but that's not a full framework.
Yeah, but I want to compete there too.
Yep. Let's see. I think that is easier than AMD ones.
What do you mean? On which?
The ones that runs inference kernels on Mac. I think we are kind of already winning that front.
See, the problem with that, I think the problem with the run inference kernels is you'd have to be. These things aren't good. They're just easy. Like these run inference kernels things, like Olama.
Yeah.
Olama's not good.
Yeah, they are not good, but they are good enough. And I think most of the time being good enough decides what would be the dominant framework on certain hardware, on certain tasks.
I think Olama, their strength is in their distribution and packaging.
And that's what dominates. Let's decide like what's the dominant framework. That's like Torch. Torch is not the best on anything.
No, but I think that like you have a different target audience, right? I think Olama is downloaded by like the kid who heard about AI who can't code. He's like, I'll get AI to do my homework. Olama.
Yeah,
Right.
but that's how the dominate software happens, right? It's like people download trash things, but they still happy with it.
I don't think this is how the dominant software happens. I'll give an example, right? Like Napster and Kazaa are gone. BitTorrent still exists. Every kid who wanted to pirate Eminem albums downloaded Napster. It's gone. No, I mean, I think, and then if you want to give us something of being you want an 80% chance of being the dominant framework on something in 3 years? TensTorrent. If we pivoted to TensTorrent tomorrow, I guarantee we could crush what they have. Exactly, and that's why we do AMD. No, I also think it's kind of your success is then tied to Tenstorrent success, which
Our success was already tied to AMD's success, right?
yeah, our success. That's a good boat to be on.
Is it? Yeah.
I made $400,000.
Okay. Yeah. Okay.
AMD's success is a good boat to be on. I'm happy to tie ourselves to AMD. Wait, you don't think AMD? You think AMD is going to fail?
Define fail. Do you think Google's failing?
No, I think Google's actually more successful than AMD. I think Nvidia and Google are like real winners in AI.
Agree.
I think like Cranium is going to fail.
I also agree.
I think Elon's actually going to end up succeeding.
That's my bet. So
That he's going to succeed?
yes.
Yeah, I mean, he's just too. Oh, he cares about this too much. He's going to succeed.
Yes. So
He'll get it. He's slow. He's slower at this than us, but he'll get it.
yeah. So I think that's a final boss.
What do you mean, Elon?
No, the new coming ones, not the current ones. So that's why.
Oh, well, no. I mean, I think Google is actually. I think Google's going to do really well.
Yeah, and I think Jax will support other things really well.
I don't.
Yeah, but that's just the difference.
Oh, you think Jax is going to start supporting GPUs really well?
Yeah.
I don't think so. I think Google's going to figure out how to externalize their TPUs before they figure out how to make Jax support GPUs. Why does Google want Jax to support GPUs?
Because they want to be like dominant from work.
But why don't they export their hardware?
They are also doing that.
But next, you're going to tell me that CUDA is going to start supporting AMD GPUs.
No, that's different.
Why?
I don't know who's going to work on that.
Who's going to work on making CUDA work on AMD GPU, making Jax work on AMD on NVIDIA GPUs? Do you think Google's going to put a concerted effort into making their framework work on their competitor?
It's not their competitor, right?
It exactly is their competitor.
I don't know.
Google. If you're in Google Finance, you start looking around. You're like, how the hell is NVIDIA worth more than us? We have a better AI chip than them. In a lot of ways, the TPU is better. You know, it's the normal things Google struggles with. They struggle to actually like platformize these things.
Yeah.
But I think Google will figure it out. Google's selling their chips to Anthropic.
Mhm.
They're writing a low-level kernel interface for Anthropic. This is all the Palace stuff. It's all open source. They know the labs won't use it otherwise. So I think Google is doing better at this, but I believe Google will sell TPUs long before Jax supports NVIDIA in a real way. It kind of can. It's not really designed. I mean, it would require some rethinking to their. It's designed for things that look like TPU topologies.
I see why that's very different.
Because NVIDIA has invested a ton of money now into making their switches do the overdues
Yes.
versus the TPUs, which have to go in a ring.
Okay.
It's just different.
Not that different.
It-
Just find another person working on this, and it'll be fine.
No, but I think it's different enough. I think it's almost like the difference between Tenstorrent and GPUs. The TPU pod looks a lot like the Tenstorrent card.
Mhm.
Whereas a GPU cluster looks a lot like a big GPU. So Elon's data center with the 3 big fans on top? It looks like it's a big.
Very big, very big.
He built the world's biggest GPU, right? It's one GPU. That's how NVIDIA wants you to think about this. I mean, Carmack was complaining that the software doesn't actually let you dispatch it like one GPU. But it is one big GPU, really. And they're working on making the unified memory as big as possible. Right? They're fundamentally betting on the. They're making the same bet that has historically won in computer architecture, which is people do not want
Split stuff.
split stuff. Yeah.
Yeah.
So I think they're very different.
Okay.
But no, I give us so much higher than 0.1% chance of being the dominant framework on AMD.
Okay, maybe 0.5.
But how many people you think are going to start using USB GPUs?
If it works and Comma can use it, and I will believe it. Yes.
Yeah, I mean, it's gonna work.
Yeah, maybe more first.
Well, you have to use Tinygraph for that.
Yes, that's the problem. But yes.
I don't think that's a problem. What do people want to do? They want to run their LLM or their diffusion model on their Mac, but fast.
Yeah.
So they plug a 5090 in, and they run it. Yeah, I think we can. I mean, I think we can sell 10,000 of these, and then it forces people like Olama to use Tinygraph. If this hardware starts to exist, it forces people into our ecosystem.
Yeah, facing that.
But all right, so am I really doing the contract? You guys, not excited?
It's probably like, oh, you cannot do nothing at all at it, but not all.
But is that what you want me to work on? I'm here to support the contract as best as I can. What do you want me to work on?
We're going to work on the contract.
What I would do today is I would start looking into doing the memory layout and confirming that if we write stub custom kernels for flash attention, that the memory usage is
Yeah, so
appropriate.
that's what we are kind of already doing.
Oh, you're doing it. Who's doing it?
Spreaders doing it. I mean,
Well, he's working on the kernels.
yeah, you would first need to have a kernel, then look into them.
No, you don't. No, just write a stub kernel. What do you mean? Well, do you want me to do this, or do you want to do it?
That we can discuss that later.
No, I think it's like a stub kernel. Like you can just stub out flash attention, even if it doesn't actually have the compute in there. Just put a blank kernel,
Okay.
and then the memory usage is not determined by anything inside your kernel.
Okay.
So confirm that we can fit 8192 context length for a 5B on the MI355 box.
Sure.
And then we can figure out with the kernels. So the stub kernels are not going to actually train. It's gonna nan, but that's fine. We can get an idea of the timing. We can get memory numbers, and we can get syncing working. Right? We can do all of this in pieces now too. I'll write the stub kernel. I'll do that. I'll have the common meetings next, but I'll write the stub kernel and kind of show what this is.
Okay.
It's just like an empty kernel.
Yeah, but that should work, right?
Well, yeah, but I don't know. I don't know if like the memory for everything else is fine. Is it just flash attention that's wasting all the memory? Or do we have other problems?
There really are lots other kernels there.
I don't know. It'd be like the activation is saving everything twice.
There are
We don't have gradient checkpointing, like that kind of stuff.
Yeah, but that we kind of also know that we need to implement. So
Oh, well, but that's independent of custom kernels.
yeah, so
Right.
so if
So what?
conditioned on that we probably already need this. I don't know what.
We can work on a lot of this in parallel, right? We can work on a lot of we can work on there. I really see 4 parts to this. I see 4 parts for the 4 other people who work here. There's the high level trainer part, which is running the trainer and like stubbing out each one of these parts. And then the parts are we need a flash attention and a gem kernel, forwards and backwards. There's the custom kernels. There's the data movement, which is like when Imogen started to work on with the CPU offload. How fast is that CPU offload copy? So there's the driver part of it. There's the kernel part of it, actually writing those kernels, and then there's the visualization to figure out why these kernels are slow and how we can make these kernels faster, and just take a look at this whole thing and figure out where the bottlenecks are. Right? It's these 4 things. Look, I try my best to break this out to tasks, and then I think that's the only 4 things. I don't think there's more. But again, if there's anything else I can do then this leaves me open to support, and I'll do whatever the worst grunt work is. I don't know if you're you're frustrated with the syntax of the custom kernels, or you're frustrated with the Python speed, or you're frustrated with the CI taking too long, or whatever.
I'm frustrated with the open path regression.
Do you want me to fix the open pilot regression? I can do that.
No, I'm fixing that.
You got the open pilot regression. Okay.
Yes.
Okay. You do the open pilot regression. I'll do the stub kernels. And with the stub kernels, we can kind of kick this off, and we can actually look at each individual piece, because I should be able to stub pretty much everything.
Yeah, then we can run that with a null backend and see.
Yeah.
If these have something wrong.
Yeah, we run this with the null backend, and like, let's go for this. Like, you know what it was like looking at the DSP and being like, I gotta do this in 12 milliseconds. It's taking 1200 now. I'm 100x off. And every day it got a little bit faster and a little bit faster and a little bit faster, and then it did it in 12. And I would say that, like, yeah, sure, there was 30% of the DSP contract we didn't end up merging, but 70% is like all the fundamental base stuff now is there for the DSP, and TVM doesn't have that. TVM has a unmaintained terrible fork for the Qualcomm DSP because it's different. Like, the DSP was so valuable to do. I think the GPU is too, and I think I mean, yeah, these big data center GPUs, we should, we should really just do what pays us money. But
What's that?
we should really like, I really like that this one pays us money.
Oh yeah, sure.
Because it's worth it to somebody, right? Let's provide value for other people. But all right, cool. So I'll write the stubs today. Yeah, Quasland, don't get too hung up on if the reverse engineering stuff's annoying, I can take a look at it. Just like parsing out the binary format, I'm very good at that. But yeah, no, I mean, we want to just match the tools we have. And then Nimiljen, did you ever get stuff up and working for testing all the copy to CPU? Should all be fast?
It is fast, but yeah.
Cool. Yeah, I mean, we might have to
When it's
move to like,
graphed, yeah.
what do you say?
When it's graphed.
When it's
Yeah, because I mean, when it's graphed, it's fast.
When it's
It's
what?
full PCI speed. When it's inside graph, I mean.
when it's graphed. Oh, yeah, it should be fine. Yeah. Yeah, we'll check that. I mean, I think we're gonna have to do better all reduces too. Like, I think the all reduce right now is like, it's all a unified memory space effectively. Okay, we have it all reduce using the DMA engine, but we don't use the DMA engine. I don't think we need that level of overlapping to get it, but we'll see. All right, cool. I'll do stuff today, and then we can kind of see what the individual pieces are going to have to be. But yeah, I think we should be able to have something training by the end of the year. I think we should have stuff that's pretty close to state of the art gem and flash attention on the MI355X. And then we can push to things like, has anyone submitted FP8 stuff? Is there any FP8 stuff yet?
Oh, I don't know. Is it out? I don't think it's out yet.
I think they released the new training stuff, but
Oh, they haven't. Because last week I checked, it's not out yet.
oh, it's not out yet. Okay. Oh, you mean yeah. I'm curious
because we
yeah.
didn't submit, so we are not able to see what other
Oh, I see. Okay.
Yeah.
Okay. Well, yeah. When that comes out, we'll see. I hope someone did FP8 and we could just match FP8, because that's why I got a number put in the contract and not a because if we get FP8, I think we hit all 4 of them, get our $1.6 million, and then I give us easily a 20% chance in 3 years for being the dominant framework on AMD.
Right?
Easy.
Love the energy.
No, you really don't think this is? You'd wait.
No.
Would you take a bet at 1,000 to 1?
I'm the one who can change this, so no.
Yeah, I mean, there's
insider. So
no, but there's no way it's 1,000. There's no way.
years because you have the energy to make that number higher.
But it shouldn't be my energy. We have to just succeed at this technical problem.
Yeah, no to that.
But it's not an energy. It doesn't have anything to do with like you know what? This isn't some like bullshit space where like hype matters. This is a real space. Just make our shit run faster than the other shit, and then people will use it. Yeah.
Faster.
Yes, make our shit faster. All right, cool.
Bye.
All right, bye. Good meeting.